All right, in this video we're going to build on the idea of types of reactions. I'm going to put a couple of skills together that we already know. We're actually going to do a little of what is called predicting products. Predicting products. Now, you know that reactants and products, the term products are the things on the right-hand side of the reaction. And so what I have here is word equations that we need to finish. Okay, so in the very first one, I've given you the whole reaction. Hydrogen gas reacts with chlorine gas to produce hydrogen chloride gas. And I need a balanced reaction. Okay? And so what's going to happen is it says hydrogen gas. That's going to tell us the phase. That's going to tell us phase. That's going to tell us phase. Okay? So when I have hydrogen gas, first thing I need to remember is that hydrogen is one of those things that are diatomics. Now, quick review just to make sure we understand. There are 7 diatomics. If you did not catch this in one of the other videos, make sure you get this. There are 7 things that show up in pairs. I call them twins. Everybody knows that we don't breathe in O, we breathe in O2. Everybody knows that. You've heard that before, but you don't know why. There's 7 of these guys. They're in pairs when they're by themselves. Did you catch that? They're in pairs when they're by themselves. There's 7 of them. Here they are on the periodic table. N2, O2, F2, Cl2, Br2, I2, and H2 way over here. Okay? So the quick shortcut is they make a 7 on the chart, and they start with number 7. N2, O2, F2, Cl2, Br2, I2, and H2. So it's N2, O2, F2, Cl2, Br2, I2, and H2. Okay? If you need to pause the video, make sure you write those down. But those are the 7 diatomics. They're only in pairs when they're by themselves. Make sure you write that down. Only in pairs when they're by themselves. All right? Now, a couple of different teachers teach it in different ways. Sometimes they'll take these and make it into a word. Here's all 7. 1, 2, 3, 4, 5, 6, 7. Okay? Called Brinkelhoff. It's a made-up word. Okay, but it's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. That's one way to do it, or to find the 7 elements on the chart. Either way, shortcut, all right? They're in pairs when they're by themselves. So let me erase that real quick, and let's do this practice problem. You may have already known that. If you didn't, make sure you wrote it down, okay? So it says hydrogen gas. Now, hydrogen is one of those 7, so it has the 2. So you're not going to actually have H by itself. You're going to have H2. Reacts with, magic word, plus sign, chlorine gas. Chlorine, look where chlorine is. He's right there. So he's going to be pairs. Chlorine gas. So there's the phase. It tells me it's gas. To produce, okay. Magic words, react with, that's a plus sign. Produce, to make, to yield, any of those words are the arrow. Hydrogen chloride gas. Hydrogen and chlorine. So let's check our charges. H is +1, Cl is -1, so that's the correct formula, HCl. Gas. All right, so I have all the correct formulas. Hydrogen, chlorine. All right, great. But the whole reaction's not finished. So I know this is right, and this is right. Now finish the whole thing. 2 H's means I need a 2 there. 2 chlorines means I need a 2 there also. So I have 2 H's, 2 H's, 2 Cl's, 2 Cl's. That's the balanced reaction that come from these words. This is a huge skill. And the reason it's a very important skill is because when you read it in a book or in a lab, you have to be able to come up with a formula that goes with the English words that you read in the lab instructions. Okay? So in this first one, I gave you all of it. Okay, you didn't really have to predict very much. Predicting is really going to take place when we start here. Let's look at that one. Lithium reacts with calcium chloride. Okay, with. That's going to be our plus sign. Reacts with. There's our plus sign. Okay. So lithium reacts with calcium. So there's my plus sign. Calcium chloride. Anytime you write a formula, you got to check your charges. Ca. What's this charge? +2. Chlorine, -1. Okay, quick reminder. +2, -1. Is that the correct formula? No, you got to switch them. All right, now I've got the correct formula. So lithium reacts with calcium chloride to produce blank. It doesn't tell me. But in the last videos, we learned the type of reactions. A single reacting with a compound is a single replacement. So these guys are going to switch places. So Ca is now going to be alone, and Li is going to be with Cl. Now, here's really tricky. You got to really listen to this. Where did that 2 come from? Well, it was +2 and -1. It came from switching charges because it was with calcium. Is it with calcium anymore? No. So do I move the 2? No. The 2 came from the calcium. Oh, I wrote a new formula, so I got to check my charge. Lithium and chlorine. Lithium is right there, +1. Chlorine is -1, so that equals 0. So I have correct formulas. Now, reminder, anybody that stands alone, like lithium and calcium right here, you don't have to check charges. There's nobody to switch with. So I have my correct formulas. Is the whole thing correct? No. 1 lithium, 1 lithium. Good. 1 Ca, 1 Ca. Got it. 2 chlorines, 1 chlorine. Okay, I need a balance. We know how to do that. Who did I mess up? I messed up my lithiums, which means a 2 there. I think I'm done. Check myself. 2 lithiums, 2 lithiums. Got it. 1 calcium, 1 calcium. 2 chlorines, 2 chlorines. It's called predicting the products. I predicted what would be made because I knew that this was a single replacement. Now, many times you are not going to come back in here and write calcium plus lithium chloride. You could, but most times they're not going to ask that. They're going to ask, they want to know the whole reaction. So they gave you the beginning and you finished it. Read the instructions carefully on any question you do. If they ask you to put it back into words, then take these and put them back into English words. But most times, they're not going to do that. Let's try another one. Okay? Let's say we had one like this. And if I get ahead of you, just pause the video. 3-heptene, and they give you the formula. That's nice. Burns. Burns completely. Which kind of reaction do you think that is? When something burns, that is combustion. Okay, so we're going to have C7H14. How does something go through combustion? All combustions are the same. You react with oxygen to yield, and it says completely, to CO2 plus H2O. So really, they didn't have to tell us much. They just had to tell us what was burning. So were we burning propane or butane? In this case, it was a 3-heptene. They gave us the formula, and you just do the reaction. Now you balance it. 7 carbons means I need a 7 there. 14 H's means I need 7 times 2 is 14 there. Remember, you always balance your oxygens last. They're usually messed up the most. So I have 14 and 7 oxygens. That's 21. What number goes right here to give me 21? Nothing. So what do you do if you have an even? So I have a 2 and a 21, an even and an odd. You go out front and start with a big 2, and you just redo it. When you multiply by 2, evens stay even, but odds now become even. So let's redo it real quick. Now, how many carbons do I have? 14. All right. 14 times 2 hydrogen, 28. 14 times 2 hydrogen. All right. So I got my carbons fixed, and I got my hydrogens fixed. So that is 28 oxygens right there. And that is 14 more. That is 42. 21 times 2 is 42, and I balanced it. Now let me give you a big hint. This was bigger. How did I get such big numbers? Whenever you see a formula that has bigger numbers here, you can expect bigger numbers with your coefficients. Okay? When I'm done, I don't need any of that. There it is. Matter of fact, I always want to check myself. 2, 21, 14, 14. Make sure that you can't reduce that. Okay, every once in a while, I'll have a student that will double it and didn't need to. And in this case, I can't take a number out of all 4 places, so that's the right answer. Okay? But all they gave me to start with was what the compound was, and it was burning completely. And I got the whole reaction. Why? Because I know the types of reactions. Let's look at the next one. Ammonium sulfate. Ammonium, I've memorized that to be NH4 plus 1. Sulfate, memorized SO4 minus 2. See how I'm checking charges? Switch them. 2 goes there, parentheses. 1 goes there, I don't need it. Ammonium sulfate reacts with, there's my plus sign again, there's my plus sign, calcium phosphate. Calcium plus 2, how did I get that? right there off the chart. Phosphite, I memorized that, PO3 minus 3. So when I switch them, the 3 goes there and the 2 goes on the outside. Got it. To make, to yield, produce. Okay, and I ran out of little room, so I got to be careful here. What kind of reaction is this one? Compound with a compound. That's a double replacement. So, or boy, girl, boy, girl. So that boy, NH4, is going to dance with that girl, PO3. Learned that in the last video. So boy is with girl. Now, you can do plus, minus, it doesn't matter. But this plus is going to be with that minus, and this plus is going to be with that minus. Ca is with SO4. Now, got to be careful. Where did that 2 come from? Well, when I check my charges, plus 1 and minus 2, they came from these guys being partners. Are they partners anymore? No. So I can't carry that 2. Why do I carry the 4 and this 4 to the other side? Because I memorized the polyatomic, and those numbers are part of the polyatomic. That one's not. So I don't carry that 2. This 3 and this 2, do I carry them to the other side? No, I don't. Because it was plus 2 and minus 3. That's where those numbers came from. But they're not with those partners anymore. Oh, so when I rewrite them over here, I got to check my charges. Plus 1 minus 3. That means that formula looks like that. And plus 2 minus 2, that equals that. Okay? Now, I got that a little messy, so I'm going to fix that real quick. All right, plus 1 minus 3. Plus 1 goes there, the 3 goes there. Got it? Plus 2 minus 2, they go away. Correct? Correct formula, correct formula, correct formula, correct formula. Now check them all. Do the whole balancing. 2 NH4s and 3 NH4s. They both go into 6. That means I need a 2 there and a 3 there. A 3 gives me 3 sulfates, which means I fixed that. So I've got 6 NH4s, got it. 3 SO4s, got it. 3 CAs, I've got that. 2 PO3s, 2 PO3s. So I'm done. 3, 1, I don't have to write the 1, 2, and 3. This is called predicting the products. They give you the front half and you finish it. Let's do one more real quick. I'm going to erase off the bottom here. I'm going to do one more. Okay. So if it said potassium reacts with oxygen gas to produce blank. All right, potassium, okay, I know what potassium is. Reacts with, there's my plus sign. Oxygen gas, reminder, oxygen's right there. He's all by himself, so he has pairs. Oxygen gas to produce, that's all it tells me. All right, that's a combination reaction, so I just put the 2 parts together. Okay, just put them together. Synthesis reaction. So I'm going to put K and O together. Now, I made a formula. So a quick reminder, every time I make a formula, I have to check the charges. So K is plus 1, O is minus 2. So plus 1 minus 2. So the correct formula is that. Now, quick question. Where did this 2 go? Well, it's only in pairs when it's by itself. It's not by itself anymore. So when you put it with a partner, you got to check charges. Plus 1, minus 2. So when you switch them, the 2 goes there. Correct, correct, correct. Got it. Now, check the whole thing. 1 potassium, 2 potassiums. 2 oxygens, 1 oxygen. Well, with 2 oxygens, I need a 2 there to make that work. Well, that messed up my potassiums. That's 4, and there it is. 4 potassium, 2 oxygens, 2 oxygens. Can I reduce this? It looks like it. 4 and a 2, but remember what's here. That's a 1. And so I don't have to write it. I'm going to write it right now just so you can see it. Can I reduce 4, 1, 2? Nope. The only way you would ever reduce something is if this is wrong, just to pretend. Let's say I had 4, 2, 2. Oh, there's a number in all of those, so I would have to reduce it. But in this case, the real answer is 4, 1, 2, and I can't reduce it. That would be my answer. So you're going to get to try out doing predicting products. Be careful, you've got to always check your charges. And when you check your charges, then you set up your reactions. Is it single replacement, double replacement, combustion? And then put your partners together, check your charges, and then finish them. Good luck. You'll do great.